So I realized that maybe I should have explained a little bit about what I mean by pick another number that's going to make this work. So we already know we have points at -6 and -8. Those are my x-intercepts. Again, so they go in here. If I average those, or if you do it graphically, the vertex has to be in between them. So the x value of the vertex, that h from our parabola or graphing form, has to be somewhere along -7. So you would have to plug that in up here. But what I want to do is make sure I show you what I mean by, since I can't use my y-intercept because they didn't give me a graph big enough, I got to basically put another number in there. And you don't want to do 0 because that's what would give you -48. So you got to play around a little bit because whatever you plug in here, you got to make sure it's going to give you an output that's going to fit on this graph. So that's the part I don't like about this delta math. So these are all negative. And so unless I put a negative number in here to make this positive, this is just going to keep getting more and more negative, and I'm never going to fit it on there. So I'm just going to try -3, and I don't even know if it's going to work. But when I square -3, so I'm going to show you what I mean. I've got to put it in there and square it. -14 times -3 minus 48. And so what that means is this part of it right here I have to do first, and that becomes 9 because -3 times -3 is 9, but this negative is still sitting out there. A -14 and a -3 is going to become plus, and 14 times 3 I believe is 52. Again, you would just punch that in a calculator, and if you do this all in a calculator, that's great, but make sure you put parentheses around what you're squaring. And then -48 at the end. And so I'm going to do these two first because that's easier. 52 minus 48 is actually 4, pretty sure. And then plus -9 gives me -5. So that means -3, -5 would be a value on here. And then again, since this is where my vertex has to be somewhere on here, I would have to plug -7 up here to get it. And that's definitely a calculation you're going to have to do in a calculator because they threw some big numbers at you. But what I would be able to do is reflect this as 1, 2, 3, 4 away from that value. So I would have to go 1, 2, 3, 4 more away. And again, it kicked me outside. So that means I would have to come up here and maybe try -2 or try -4 because they're not giving me a graph that's very helpful. It's too bad we can't move this thing around. So I guess maybe my point is on a delta math, if you get one with a big number over here and you don't want to play this game, just hit next one and it'll bring up another equation, and you just maybe do that until your equations are all y-intercepts that are like reasonable, that'll fit on the grid. I don't care how many times you have to pop through to pick up a new one. That doesn't matter to me. Does not matter at all. So what I'm talking about is up here, be like, oh, new problem. Ah, that is a y-intercept I can graph. Boom, it's right there, easy. So if you're going through this, if you don't want to play this little extra game of finding points somewhere else other than the y-intercept, and that's going to be like your slam dunk 4th point to get to the 5th point, again, new problem. I don't want to play with that one, so I go new problem. And then hopefully, there we go, 24, at least a little bit more manageable to play around with, and everything's positive. So hit new problem, and again, I think I only put that you had to do 4 of these, so hopefully that helps.